All right, so we have a bunch of vertex form questions we're going to look at, specifically 10 B and C. So let's look at B first. How can you use the values of A and Q in the equation of this, okay, to determine how many x-intercepts the graph of a quadratic function has? So let's just write a random one so we can look at this, okay? Y equals 3x minus 1, whatever, plus 5, okay? These are the two terms we're going to look at, and they're going to help us to figure out how many x-intercepts the graph has. Basically, most questions are going to have two. Let's draw the three options. Okay, there's this, this, and this. That's too hard to see. Okay, there can be either 1, 2, or 3, 2, 0, 0, 2, or 1 intercepts. Basically, the question's saying if you know what the vertical shift is and you know whether or not the graph is opening up or down, you can tell how many intercepts there's going to be. So for example, in the one I just drew, it's a plus 5. Really, the horizontal shift doesn't matter, but it moved 1 to the right and 5 up, and it opened upwards. So instantly, I know that there's 0 intercepts. However, if I change these, so instead if I made this, let's say, -5, okay, that means instead it's going to be down here as the vertex opens upward. Now it's going to have 2 intercepts. And again, if I had changed this to make it a negative number, -3, so the vertex would be down here, but it would open down, and this would again have 0 intercepts. If you end up actually not having a vertical shift at all, so it's on the line, that means you're always going to have 1. Okay, so looking at those two terms can help you tell, okay, did I move up or down? And then am I opening up or down? Drawing a quick sketch is the best way to see really quickly how many intercepts it's going to have. This second question is saying just write an equation that has 0, 1, and 2. Okay, using what we already know, what we just talked about, I'm going to do some examples really quick. Okay, so if I have 0 intercepts, I'm just going to sketch it first. I'm going to say I want a graph that goes like that. So I'm going to say, okay, I want it to go up by a couple. Sure, whatever, I've got +3 there. In this case, I want it to go to the right, so I want to have, like, I don't know, -2, whatever. And then it's opening upwards, so I need to have a positive A value. Bam, that is 0 x-intercepts. Okay, now let's do it again, but with 1. So in this case, I need to have something that's actually touching the x-intercept, just like that. So again, I'm going to set up my parabola to start. I don't have any vertical shift, so it's +0 or nothing at the end, no vertical shift. The horizontal shift doesn't matter. I actually did plus a little bit, so that's fine. And then again, the opening upward or downward doesn't make a difference. In this case, I made it open upward, so whatever, I'll make it a positive number. And that has 1 x-intercept. Perfect. So the important thing for that was that there was no vertical shift. The last one we'll do, 2. Okay, so to have 2 intercepts, it's just normal parabola like that, no problem. So let's graph it. My vertical shift in this case, I'm going to make it go down. Whatever. I actually didn't want to make it go horizontal at all, so I got +0. And then in this case, I had to make it open upwards, so I got a positive. Let's change things up. Let's actually just do another one. We'll make it open downwards just to make it different. So in this case, I made it open downwards. That means that, and here my vertex went up, so I need to have something like that. And there we go. Now we have a good 2 intercept question. I want you to understand there's an infinite number of answers for these questions. You're just trying to understand, and the core ability is that if you have a graph or an equation, you should be able to sketch a graph or vice versa in about 5 seconds. It should not take very long. That's it.